In this video, we're going to look at how to find the intersections of the graphs of two equations. So let's begin with reviewing what it means by an intersection. An intersection of two graphs is a point on both of these two graphs. So recall that a point is on a graph if its coordinate is a solution for the equation. Therefore, according to this definition of intersection, we come up with the following principle of finding the intersections of graphs of two equations. It says that to find the intersections of the graphs of two equations, we need to solve the system consisting of these two equations. We're going to look at a few examples and abide by this principle. Here's the first example. We're going to find the intersection of the straight lines given by y equals x plus 2 and y equals 2x plus 1. The illustration of these two graphs is on the figure up here. So we're looking for the intersection, which is this point, on both of those two graphs. As we have mentioned, we're going to abide by the principle that we have just described. So what we're going to do is going to set up an equation system consisting of both of these two straight line equations. That is, to solve this problem, we're going to consider the system of equation consisting of y equals x plus 2 and y equals 2x minus 1. If we're able to solve this equation system, namely, find x and y that would solve both of these two equations simultaneously, then those two numbers, x and y, are going to be serving as the coordinates of the points at the intersection. Therefore, we would start to solve this equation. We would use substitution. The substitution method to solve this system. All right, and specifically, from the second equation, for instance, we know that y is equals to 2x minus 1. Hence, we could plug this expression into the first equation to replace your y in the first equation, and we will end up with an equation of just one variable. Hence, we will reduce the problem to the following equation, which says that 2x minus 1 is equals to x plus 2. And manipulating this equation a little bit, we end up with x equals to 3 simply by moving the x to the left-hand side and the constant -1 to the right-hand side. So we end up with x equals 3. And since y is in turn equal to either x plus 2 or 2x minus 1, you could use either of these two expressions. And what you're going to do is going to be plug the 3 into the place of x. Say, for instance, let's use the first equation, x plus 2, and we're going to plug the number 3 into the place of x, and we will end up with 5 as the answer. Well, once we get both x and y, we could conclude that the intersection is the point whose coordinates are given by x equals 3 and y equals 5, respectively. And that is our solution for this problem. In this example here, we will try to figure out the intersection of the parabola given by y equals x squared minus 2x plus 1 and the line y equals 1/2 x plus 1. The configuration of these two curves are given in this figure over here, so we are expecting two intersections. Well, just as we have done in the previous example, we would be considering the system of equation consisting of both of those two equations. Okay. Now we would use substitution again. So use substitution. And what we're going to do is going to substitute the y in terms of x in the second equation and plug that into the first equation up there so that we eliminate the y variable and end up with an equation of only one variable, namely the x. And consequently, we will end up with this 1/2 x plus 1 equals x squared minus 2x plus 1 condition. Now to solve this equation, what we would love to do is simplify this expression a little bit. For instance, we could move the x to one side and end up with this 5/2x equals 0. So that would be the equation that we are going to solve. It turns out to be a relatively simple quadratic equation to solve. We don't even need to use the quadratic formula because we could easily observe that this equation could be factorized into the product of these two first-degree terms. And from this factorization, we must have either x equal to 0 or x minus 5/2 equals 0. That is, you will have x1 equal to 0 or x2 equal to 5/2. And with respect to each solutions in terms of x, we will have a corresponding y. Consequently, y1 is going to be equal to 1/2 x1 plus 1, which is precisely 0 plus 1, and we get 1 over here. And y2 is going to be 1/2 x2 plus 1, which is going to be 9/4. Hence, we conclude that those two intersections are given by the following 2 points, 0, 1, and 5/2, 9/4, respectively. And those are the solutions for this problem.